name is B. Santhosh Kumar, Assistant Professor, Institute of Aeronautical Engineering. My subject is image processing. Today I am discussing about problem solving on arithmetic coding. So, image compression is a process applied to a graphics file to minimize its size in bits without degrading image quality below an acceptable threshold. By reducing the file size, more images can be stored in a given amount of disk or memory space. The most common compression methods are JPEG, tends to blurring the appearance of lines, especially at low resolutions. In contrast, lossless image compression technique retain the originally quality but not compress the image efficiently. Example, TIFF, GIF and PNG. So, image compression. So, image compression. What is the use of compression? Compression is using but a size, reduce the size of the image. We are reduce size of the image. It is one thing, and adjust the edges and smoothing and reduce noise. And another one is a filters, use mask. So these are the image compression methods. So image compression. So any of the Shannon-Fano, Huffman coding and arithmetic coding, these are under image compressions. So when we are discussing the arithmetic coding, it is nothing but it is under image compression. So this coding is using for the image compression. Arithmetic coding is using for the image compression only. So it is a process applied to a graphics file to minimize its size in bytes without degrading image quality below an acceptable threshold. By reducing the file size, more images can be stored in a given amount of disk or memory space. The most common compression methods are JPEG, tends to blur the appearance of lines. Okay, when going for the blurred images, okay, blurred is nothing but one type of noise is there. So the compression methods, JPEG tends to blur the images. Okay, most JPEG images are blurred images are there. That is nothing but a noise, and especially at low resolutions. In contrast, lossless image compression technique retain the original quality but not compress the image as efficiently. Okay, so lossless image. Suppose JPEG is a, if I am taking the lossless, then we have to change it, but data will not. We have to modify to retain the original quality. Retain original quality. So when I'm getting the retain the original quality means when it is a JPEG image, so it is a lossless image, then only it is possible to retain the original quality, but not to compress the image. Okay, it is not compressing, only retain the image. But examples are TIFF, GIF and PNG are the lossless image compressions. Okay, these are the lossless. Okay, when I'm going for the JPEG, it is a lossy image compression. Okay, so there are two major types of image compression algorithms are there: lossless image compression and lossy compression. So when I'm going for the lossless compression algorithm, to reduce the file size while preserving a perfect copy of the original uncompressed image. Lossless compression generally, but not always, results in larger file than lossy compression. Okay, it is a larger files than lossy compression. Both are very common in use. An example of lossless compression is a zip archive files. An example of lossy compression is a JPEG. Okay, so lossy is a JPEG, and what is a lossless is a zip files. So there are two major types of image compression algorithms are there: lossless and lossy compression. But what about the lossless is a algorithm to reduce the file size while preserving a perfect copy of the original uncompression images. But lossless compression is generally but not always results in larger file than lossy compression. Both are very common in use. An example of lossless compression is a zip file, and an example of lossy compression is a JPEG file. So data compression methods are lossless image compression and lossy image compression. Lossless image compressions are the run length coding, Huffman coding, and Lempel-Ziv LZV file. Okay, so these are the three types are there. Lossless methods are three types: text or program. Lossless is nothing but a text or program files. Okay, so run length coding is a one type, Huffman coding, Lempel-Ziv. And lossy methods are image, video, and audio. Image, video, and audio. So JPEG, MPEG, and MP3. So maybe lossy. Why? Because these are the images, video, audio. But it is a text or program. Text or program means maybe we have the chances to modify from the original source file. That is a lossless method. Okay, in the both the data will not loss. Only the we have to change the sizes or anything. Data will not loss. But here the data may loss, not compulsory, may loss, but size will be changed. Here also size will be changed, but it is not lossy. No lossy. Okay. So in the previously we discussed Huffman coding and Lempel-V, but now we're discussing arithmetic coding. It is under the lossless image method. So data compression techniques. What are the data compression methods are there? Based on data quality and based on coding scheme, based on data type, based on applications. So we are dividing in the data compressions of four types: based on data quality, based on coding scheme, based on data type, based on applications. So based on data quality, how many are there? In the based on data quality, lossy and lossless. If lossy is there, that quality is less. If lossless means the data quality is good. So based on coding scheme, Huffman coding, arithmetic coding, and dictionary based coding, LZ, LZW, LZ, and Barrows-Wheeler transform, run length coding, scalar and vector, Wheeler transform. In the based on data type, text compression, image compression, audio compression, video compression. Based on applications, wireless sensor networks, medical images, and specific applications. So majorly we are using the medical images like this. And today we are discussing arithmetic coding. So arithmetic coding is nothing but a data compression. It is the arithmetic coding. It is the coding scheme based on the code. So lossless and lossy compressions are there. In the lossless arithmetic, this is under data compression. But in the data compression, so based on data compression, based on coding, we are using arithmetic. So data arithmetic coding, why we are using arithmetic coding? For the data compression. Okay. So the data compression is a lossy algorithm compress data while losing some details. They reduce the number of bits used to represent the messages, even if that reduces the quality of reconstructing the data. When I'm going for the lossless algorithm to reconstruct original data without any loss, because of this, they use a higher number of bits compared to lossy algorithms. And arithmetic coding AE is a lossless algorithm that uses a low number of bits to compress data. And AE is nothing but a arithmetic coding algorithm to reduce the number of bits. Is that AE encodes the entire message using a single number bit 0.0 and 1.0. So data compressions already discussed. We are lossy and lossless. So when I'm going for the lossy algorithm, we are compressing the data. Lossy means compressing the data while losing some details. Okay, some data will be missing, but we are easily compress. But reduce the number of bits used to represent the message. Lossless algorithm to reconstruct original data without any loss. So file size is reduced but the data may be not lost. But in the lossy, file size is reduced very much, but maybe the data will be lost. In the arithmetic encoding, it is a lossless algorithm. Arithmetic coding is a lossless. Lossless algorithm that uses a lower number of bits to compress data, and AE algorithm reduces the number of bits. AE arithmetic encoding encodes the entire message using a single number between 0.0 and 1.0. Each symbol in the message takes a subinterval in the 0 to 1 interval, the corresponding to its probability. To calculate the probability of each symbol, a frequency table should be given as an input to the algorithm. This table maps each character to its frequency. The more frequent symbols, the lower number of bits it is assigned. As a result, the total number of bits representing the entire message is reduced, and it is compared to using a fixed number of bits for all symbols in the message as it Huffman coding. Okay, so each symbol, if I'm taking x1, x2, x3, x4, x5, each symbol that takes a subinterval of 0 to 1. Suppose 0 to 1 means I'm taking 0, x2 equal to 0, x3 equal to 1, x4 equal to 1, 0, x5 equal to 1, 1. Maybe I'm example taking. It is between the 0 to 1 interval, means binary code, and corresponding to its probability. To calculate the probability of each symbol, a frequency table should be given as an input to the algorithm. So, in the next figure, we will discuss the table maps of each character to its frequency. So, tables are there, symbols are there, we have to find out the frequencies. And the more frequency of the symbols, the lower number of bits it is assigned. As a result, the total number of bits representing the entire message is reduced. And this is compared to using a fixed number of bits for all symbols in the message as it is a Huffman coding. So I'm taking one example of arithmetic coding. Assume that the message to be encoded consists of just three symbols, A, B and C symbols, and analyzing some previous messages we get the frequency of three symbols. So what is the frequency of these symbols? Okay, so we have to take that frequency of the three symbols. A equal to 2, B equal to 7, C equal to 1. Okay, using the frequency table we can calculate the probability of occurrence. Okay, so we have to find out the probability of occurrence. So A, B, C symbols are there and frequencies are there. We are find out the probability of the occurrence of each symbol, but the probability is calculated as follows: frequency of a symbol or sum of frequencies of all symbols based on the frequency table. Here are the probabilities of three symbols. So here A is there, A equal to 2, that means P of A equal to 2 by 10 equal to 0.2, P of B equal to 7 by 10, 0.7. So P of C equal to 1 by 10 equal to 0.1, 0.7, 0.2. So 0.2, 0.7 and 0.1. So the probability of occurrences are dividing means arithmetic, and we have to taking as a arithmetic encoder or arithmetic coding. Can start the encoding process. In the next we are going on the encoding process. Encoding and arithmetic encoding works by representing the cumulative probabilities of all symbols on a line that ranges from 0.0 to 0.1. On the line, each symbol uses a subrange. It is as a subrange. So, given any symbol C, it starts from the value and ends the value calculating using the following equations: S plus of P of C into R. Already we know that S is nothing but a symbols. Here, S is a cumulative sum of all previous probabilities. P of C is the probability. R is the range of the subtracting starts of the end. So here arithmetic encoding is a representing of the cumulative probability of the all the symbols on a line that ranges from 0.0 to 1.0, and the symbols uses a subrange, and the symbols are C starts from value, ends with calculating the using equation S plus P of C into R. Here S is nothing but a cumulative sum of all previous probabilities, and the P of C is a probability of symbols, and R is the range of the calculating the subtracting of start from the end of the line. And in the beginning, the line starts from 0.0 and ends with 1.0. Already we know that 0.0 to 1.0. But what is the range equal to? R equal to 1.0. It is a range. Let's calculating the start and end of the values A, B, C. It is the start value and it is the end value. The first symbol A is a 0.0. From 0.0 to 0.0 plus 0.2 into 1.0, it is 0.2. So what is the probability means? Starting from 0.0 plus 0.2 is the probability value into 1.0 equal to 0.2 is the start value and end value is a 0.2. So 0.0 to 0.2 is the end value. And the symbol B is the 0.2 to 0.2 plus 0.7. Why? Because I am taking values means here already we know that 0.7. So 0.2 plus 0.2 is the first value, 0.7 into 1.0 equal to 0.9 is equal to 0.9. And what is the third value? Here 0.1 is there. Here 0.9 already is there. 0.9 plus what is this value? 0.1 into 1.0. It is a 1.0. So 0. So what is the A value here? It is 0.2, 0.9 and 1.0. It is the start of the value. Here end of the value. So the symbols are good and representing as a graphically showing this one. So the input values are already we know that what are the input values? 0.2, 0.7, 0.1. But what are the final values we got? 0.2, 0.9 and 1.0. Finally we got the values. Okay. These are the arithmetic coding. You can observe here 0.0, 0.2 and 1.0. But finally what we got value? Between the A 0.0 to 0.2, between the A and B 0.2 to 0.9, between the C 0.9 to 1.0. What we observed from the input values to the output values. The first symbol starts from the start point of the line 0.0 and the last symbol ends with the end point of the line 1.0. Okay, starting is a 0.0 and end value is a 1.0. Okay, but if a first symbol start the value is 0.0, end is 1.0. A symbol C covers the percentage of the range. So C equal to percentage of symbols. Okay, C percentage of symbols range correspond to each probability. For example, the symbol B covers 70%. It is one example, and the line because of probability. If B is covered 70% means it is nothing but a 0.7. So the first symbol starts from the same point of 0.0 to 1.0 and symbol C covers the 1.0. So what is the total probability of covering of B equal to? If I am taking it is a 70%. 70% is nothing but a probability is 0.7%. So static arithmetic coding. Consider an half open interval low or high. Initially intervals is set from 0, 1 and the range of high to low is a 1 to 0. When I am going for the low equal to 0 and high equal to 1, always the values are like this only. The intervals are divided into cumulative probabilities of n symbols. For the example, n equal to 3, P of A equal to 1 by 2, P of B equal to 1 by 4 and P of C equal to 1 by 4. Okay. So we are considering as a half open interval. Half open means low and high values are there. So these are the 0 and 1 values are there. High to low is a 1 minus 0, 1. Interval is dividing into cumulative probabilities of a n symbols. And n equal to 3, P of A equal to 1 by 2, P of B equal to 1 by 4, and P of C equal to 1 by 4. So 1, 3 by 4, 3 by 4, and the last values are there. So what are the values? 0 to 1 by 2, 0 to 1 by 2 and 1 by 4. So what is end value is a 3 by 4. So I am taking as a average 1 by 2, 5 by 8, 11 by 6. Why? Because the three ranges are there, A, B, C. So what are the average values from A, B, C? Here also A, B, C. What are the probability? 23 by 32, 47 by 64. 47 by 64, 96 by 178. So any value of the range 47 by 64 and 96 by 128, it encodes the BCCA. So what is a arithmetic value is a BCCA, B to C, C to C to C and C to A. So B to BCCA is the probability value of 47 by 64, 96 by 128. And adaptive arithmetic coding. Consider in half open interval, low high initially interval is set as 0 to 1. I am taking same continuation of this one, 0 and 1, 0 equal to low and 1 equal to high value. So the half open interval, initially interval is set as 0 comma 1 and range equal to high minus low. That means 1 minus 0 equal to 1. The interval is dividing into cumulative probabilities of n simmers in each having. So 0 to 1, 1 by 3 and 2 by 3. Okay, the range is like this. ABC between the 0 to 1, between the low to high, what are the probabilities? 1 by 3 and 2 by 3. So what are the probability exact values? 0.33, 0.4, 0.58, 0.6. So finally what we got is means 0.6 to 0.6. So 3 to 0.3 to 0.6 is there, ending in 0.63 to 0.63. So when these are the nearby values, that is a BCCA. The arithmetic coding is a BCCA value. So a static zero order model used for the first example I shown. In the dynamic second example is the accurate value. But initially we have to take the frequency distribution. But every time we process a new symbol, update the frequency distribution. So in the example 1, what we got, what is the result? Example 1. In the example 2, what is the result? We discuss now. In the a static zero order model is used for the first example. Okay, first example is nothing but a static zero model. And example 2 is a second example, it is a dynamic zero. Initially we have the frequency distribution. So every probability value, every symbol we are dividing as a frequency distribution, and every time we process a new symbol, update the frequency distribution. So in the next examples we are discussing briefly about static and dynamic distributions of each example. But what are the properties of arithmetic coding? The dynamic version is not more complex. Here static and dynamic two are there. Static So these are different codes are there, but finally what we have to do is frequency distribution. So the properties of arithmetic coding, the dynamic version is not more complex than the static version. The algorithm equates log minus log pi. Already we know that what is a minus log pi? We are finding out the entropy or word length or code length. So the dynamic version is not more complex than the static version. The algorithm allocates minus log pi number of bits to a symbol of probability pi wherever or not the value is low or high. Low or high, low to high is there. No? So low or high. But unlike half-end coding, if I am not using half-end coding, going for the arithmetic is a fixed to variable coding. It is a fixed to variable coding scheme. Unlike half-end coding, it is a fixed to variable coding. It is the arithmetic coding is a variable to fixed. Okay, fixed to variable coding is a half-end code, and arithmetic code is nothing but a variable to fixed coding. Hoffman coding is for the probability, to finding out the probability. Arithmetic coding is nothing but a frequency distribution. So what are the properties of arithmetic coding is nothing but it is a dynamic version, is not more complex. Why? Because static version also there. But in the algorithm allocates minus log PI for entropy or code word, the number of bits to a symbol of probability PI, wherever or not the value is low or high. But the Huffman coding is a fixed to variable coding scheme, but in arithmetic coding is a variable to fixed scheme to capable of allocating non-interval or non-integral number of bits to symbols, producing a near optimal coding, and it is the absolutely optimal due to limited precision of arithmetic operations, and the incremental transmission of bits are possible, avoiding working with higher precision numbers. There are two main parts of arithmetic coding: update frequency distribution, update subinterval. Okay, update frequency distribution FD, and update the subinterval distribution SI. Okay, so low equal to L equal to low, that is 0, H equal to high, that is equal to 1, and the symbols of the alphabet mapped to the 1 to so on n. For each incoming symbol S, the interval is updated. So low equal to L plus low equal to what is the length L equal to L plus R into summation of J equal to 1 to S minus 1 of P of J. Range R equal to R, capital R equal to R into P of S. So what is the P of S equal to? The probability. Probability of symbols. It is a probability of symbols. So there are two main arithmetic codings are there. First one is the update frequency distribution. Second one is the update subinterval of the initial have the interval of low and high, that is 0 and 1. The symbols of the alphabet are mapped to the integers 1 to so on n. For each incoming symbols S, the interval is updated. Low equal to low L equal to L plus R into summation J equal to 1 to S minus 1 of P of J, and range R equal to R into P of S, that is a probability of symbol. So it is the low and it is a high value. So low value is for length of this one, high is nothing but a probability of this one. I'm taking one example of arithmetic coding to finding out the arithmetic coding from the given symbols probability ranges. Here example symbols are there. How many symbols are there? A, B, C, D, E, F, and dollar symbol is there. So rupee symbol is there. Probability is there 0.2, 1, 0.2, 0.05, 0.3, 0.05, 0.1. So what is the range means? 0, 0.2, 0.2, 0.3, 0.3, 0.5, 0.5, 0.55, like this. Okay, what is the values are there? Okay, the value optimal symbol, low, high, range. So I'm taking as a high value to low value. It is a low values are there, and these are the high values are there. It is a range. What is a range? Means is there. Suppose output symbol I'm taking as a 0. C. Suppose I'm taking C. Output symbol is C. What is the range? It means 0.3 to 0.5. 0.3 to 0.5. What is the range? Is a 0.2. Next I'm taking as a output A. I'm taking A 0 to 0.2. And what is the probability means? You can see here 0.2. Here E value is there. E is nothing but a, what is the range? 0.55 to 0.85. 0.55 to 0.85. What is the range? Is 0.3. Next I'm taking as a E value. E is nothing but a 55 to 85. Same as it is. So I'm taking the symbol. What is the range? 0.9 to 1.0. So what is the probability means? 0.1. Okay. So it is the symbols are there, probability and range. So they gave as a inputs. So what are the outputs are there means? What we got the outputs means? We are finding out the output symbol, output symbols, with ranges. So output symbols with ranges. Okay, low, high, and frequency ranges, output symbols. So here one example. The image a binary sequence where a equal to 3 by 4, b equal to 1 by 4. Compute the arithmetic code of the sequences. Computing the arithmetic coding of the sequences. What are the sequences? A, B, AA, AB, BA, and BB. How many are there? A, B, AA, AB, BA, and BB. How many are there? 1, 2, 3, 4, 5, 6. So 6 are there. So first I am taking as a, for A I am taking 0, B means 1 1, 0, 1 0 1, 1 1 0, 0 1. How we got this one? Okay, we can see from the table. What is we have to do? We have to compute the arithmetic code of the sequences. Okay, suppose majorly how many symbols are there? Majorly symbol A and symbol B. Only two symbols are there. So first I have to take the two symbols. That is a symbol A and symbol B I am taking. In the symbol A, what are the probabilities are there for the combination? AA is one combination and AB is another combination. Is it any another combinations are there? No. Here BA and BB is the two combinations are possible. So in the AA, AB, BA and BB. So how many are there means? Now 4 combinations are there. 4 symbols are there. Okay. So but here how many are there? Total 4 plus 2. 1, 2, 3, 4 plus 2. So total how many? 6 symbols are there. So from these 6 symbols, I am taking the 0, 0, 0 to all ones are there. Okay, 0, 0, 0 to all ones are there. So first I am dividing as a 2, 2. First to 2. This I am taking as a 0, 0, 0, 0 to 0, 0, 1. This value I am taking as a 0, 0, 0. These two values I am taking as a 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, 1, 1. So here 4 bit is converting to the 3 bit. It is converting the 2 bit. It is converting the 1 bit. So what is the final probability? C of A equal to 0, 1, 1, 0, 1, 0, 1, 1, 1, 0, all ones. So why? Because if I am taking the single bit, I am taking 0. Okay. So A is came from 0. AB is came from A. BA is came from B. BB is came from this one. Okay. So 1, 1, 0, 1, 1, 1, 1. So what is A here? A is a 0 starting from 0. A is a starting 0. A 0, 1, 0, 1. So 4 bit is converted to the 3 bit. 3 bit is to 2 bit. 2 bit to 1 bit. So it is a binary sequence ordering of computing and reducing the bits from 4 bit to 1 bit. It is another example of arithmetic coding to encode the symbols C. Okay, how many are there? 1, 2, 3, 4, 5 symbols are there. So these are the 5 symbols are there. First one, what we have to do? Probability distribution of the symbols. First one is a probability distribution. And what is a B bit? Graphical display. And what is a C1? Low, high, and range. We have to define low values, high values, and range values, and a display and a probability. We have to find the probability. But here, how many symbols are there? 1, 2, 3, 4, 5, 6, 7 are there. So probabilities are also there. Ranges also they gave. So first one, probability of distribution. Okay, I am taking from 0 to 1. What are the ranges are there? 0.3, decreasing to increasing order. So first 2 dividing, another 2, another 3 here. So middle one is like this. Okay. After then, one is divided and another one. So last, finally what will happen? Individually, how many we got that one? So finally, 1.02, 0.5, 0.35, 0.334, 0.33, 0.33. So what is the final value is here? 0.33. So 0 to 0.3, 0.3, 0.33. The probability value is 0.3. So symbols are there. See, what is the lower value? So we are increasing to decreasing order, decreasing to increasing order I'm taking. So what is the highest value here? 0.2, 0.2. So we can see here 0.2 C and A, 0.2 and 0.2. Next, what are the least values are there? After the 0.2, what are the least value? This value and B value. Okay, and B value 0.1. So what are the low values means? 0, 0.3, this one. It is decreasing to increasing order. It is from like this, and ranges are from like this. Okay, so our question is from, we have to find out the low, high and range. Low, high and range values are there. Here what we do, probability of distribution and graphical display. So probability of distribution 1.0, 0.5, 0.34 like this. So probability of distribution is there, and symbols are there like this. Okay, increasing to decreasing order of the symbols. So what is the each level? The probability distribution is completed and the ranges are completed. Display is there, low, high ranges are there, and it is a process. But here the encoding process is illustrating in the above figure H and C, in which the sorting from CAE. First, what is the levels are there means CAE level. So C to F. But low equal to 0 and high equal to 1. Already we know that low equal to 0 always and high equal to 1. And after the first symbol, C to A, and 0.5 to 0.2. And illustrating the even shrinking range or enlarging each step, the figure B after the second symbol A. What is the second symbol? A to low, high and range. Low, high and range. These are the 3D types are there. Low, high and range. 0.3, 0.34, 0.04. The process repeats itself until a terminating symbol is received. But low to high, low and high means low, what is 0.331, here 0.332. So low value is 331, higher value is 332, and the probability is a total is 0.00036. But the final step of encoding the calls of generating of a number that in the within the range is low to high, and the values are from 0.3318485 in the above example. Less obvious how to do with a binary fractional numbers. It is a nearby very fractional numbers are there. 0.33184, 0.33185, 0.332. Okay, so partially increasing the values with the probability. Okay, these are the references are there. So finally, I am concluding this one. So image compression is a process applied to a graphic file to minimizing the size of the bytes without any changes of this one, and quality of below acceptable threshold by reducing the file size. The more images can be stored in a given amount of disk or memory space. So there are two types of image compressions are there. First one is a lossless compression. The second one is a lossy compression. In the lossless compression, we are reducing the file size. In the lossy compression, we are reducing the file size, but maybe the data may be lost. So the example of lossy is a JPEG is a lossy, and the GIF file is a lossless compression. So finally, data compression methods are two types. Lossless means text or program, and the lossy is the image and image, video and audio. So what are the major types of lossless are the run length coding, Huffman coding and Lemple zip, and the lossy methods are JPEG, MPEG and MP3. So finally, data compression techniques are based on data quality, lossless and lossy, both are, and based on coding scheme, there are Huffman coding, arithmetic coding and LZ coding like this. Today we discussed arithmetic coding. It is under based on coding scheme. Okay. So based on coding scheme, data compression based on coding, arithmetic coding is one type. So based on data type, text compression, image compression, audio compression and video compression. Based on applications, wireless sensor networks, medical images, specific applications. Majorly we are using medical images in the image processing. And the data compression lossy algorithms compress the data while losing some details by reducing the number of bits used to represent the message, even if that reduces the quality of reconstructed data. But the lossless algorithm to reconstruct the original data without any loss. Because of this, they use a higher number of bits compared to the lossy algorithms. The arithmetic encoding AE is a lossless algorithm that uses a low number of bits to compressing the data. And the AE algorithms are reduces the number of bits is that AE encodes the entire message using the single number 0.0 to 1.0, low to high values. Okay, so AE is nothing but a arithmetic encoding. Each symbol in the message takes a sub-interval in the 0 to 1 interval corresponding to its probability. To calculate the probability of each symbol, a frequency table should be given as in input to the algorithm. This table maps of each character to its frequency. The more frequency of the symbols, the lower number of bits it is assigned. As a result, the total number of bits representing the entire message is reduced. This is compared to using a fixed number of bits for bits of symbols in the message as in Hoffman coding. So, example 1, assuming that the messages to be encoded consist of 3 symbols A, B, C, and analyzing the previous messages. So, A equal to 2, B equal to 7, C equal to 1. So, what is the probability value? A equal to 0.2, 0.7 and 1.0. 0.2, 0.7, 0.1. So, when going for the arithmetic encoding, it is works on representing the cumulative probability of all symbols in the line from 00 to 01. So, low to high values. And the symbol C starts from the value, and ends with the value of calculating using the following equation: S plus P of C into R. Here S is nothing but a cumulative sum of all the previous probabilities. It is depending on previous values. And the probability of symbol C and R is nothing but the range of line which is calculated by subtracting the start from the end of the line. And in the beginning, the line starts from 0.0 and ends with 1.0, and the range is 1.0. Okay, 0.0 to 1.0 range. And we are calculating the start and end values of the 3 symbols A, B, C. First symbol is A, 0.02, 0.0 plus 0.2 of 1.0, it is 0.2. Second value is 0.9, third value is 1.0. So 0.2, 0.9 and 1.0. So these are the probability ranges. 0.2, 0.9 and 1.0. So 0.2 to 0.2, 7 and 9. Ranges are 0.2, 0.2, 0.9 and 1.0. So 0.0, 0.2 and 1.0. But what are the original values? A is from A 0.0 to 0.2, B is from 0.2 to 0.9, 1.0. Okay, 0.2, 0.9, 1.0. Originally, what are the values? 0.2, 0.7 and 0.1. So it is no change, but it is partially increasing the values. Okay, the first symbol is changed from 0.0 and the last symbol is 1.0, and the symbol C covers the percentage of correspondence to its probability of 70% of the line, that is a 0.7 as a probability, that is a 70%. 0.7 is a 70%. Here example 2 I am taking as a half interval of 0 to 1, and what are the probability values? P of A equal to 1 by 2, P of B equal to 1 by 4, P of C equal to 1 by 4. So we are converting to the encoding of the interval. It is also high value to the low value. We are changing the encoding values. Here a static and dynamic. There are two types of arithmetic codings are there: static encoding and dynamic coding. In the static coding, the 0 order is used for first example. In the dynamic is a second example. Initially, we have the frequency distribution. Every time we process a new symbol, update the frequency distribution. And what are the properties of arithmetic coding is that the dynamic version is not more than complex than the static version. And the algorithms allocates is the minus log PA. That is the entropy value or code length we are finding out. If using the code Huffman coding, what is that means? Fixed to variable coding is there. If it is a variable to fixed coding, that is nothing but a arithmetic coding. And we are incrementing transmission of the bits as possible, avoiding the works with a higher order and higher precision numbers. And what are the main parts of arithmetic coding is update the frequency distribution and update the subintervals. And it is an example of symbol probability range. We are output, what are the, it is the inputs are there, and what are the outputs means where low, high and range are divided. So the input probability values are changed to the low, high and ranges are there. Here also input is a probability values are there, 3 by 4, 1 by 4. We are converted to the 4 bit to 3 bit, 3 bit to 2 bit and 3 bit to 2 bit to 1 bit. So finally two symbols are there, 0 or 1. So it is a symbol, probability and range they given. We have to find out the probability distribution and the graphical display and low high range. Here probability distribution is there, and we are displaying the images or symbols, and third one low high range or we got this one. Okay, and it is a low high ranges of the each one. Okay, thank you.
Like, share and subscribe. Hit the bell icon for more updates.